So today and over the next couple days, we're going to look at some special quadrilaterals. All right, we've talked about polygons in general so far, but today we're going to start with parallelograms and talk about what makes them special, and then we'll move on to some other four-sided shapes. All right, what is a parallelogram? A parallelogram is a quadrilateral, which means it has four sides, whose opposite sides are parallel. That's its definition. So along with that property, that the opposite sides are parallel, there are four other properties, 5 in total. All right, so down below, all right, the first one, as we just said, is that the opposite sides are always parallel. The other one about the sides is that the opposite sides will always be congruent as well. There are two properties about the angles. The first one is that opposite angles are always congruent. Now, because a parallelogram kind of sits generally a little lopsided, hopefully you can tell these two angles that are opposite are congruent. They look acute. And then the other two are also congruent. They're more obtuse. Okay. The fourth property, consecutive angles are going to be supplementary. Of course, supplementary means that they will add to equal 180. So this one acute angle and this one obtuse angle, if you add them together, always will be 180. And that works the same all the way around the picture. Right? And of course, that holds true because the opposite sides are parallel. These would be consecutive interior angles, which we learned long ago, that consecutive interior angles will always be supplementary. And the fifth property concerns the diagonals. When we draw in the diagonals, what happens is they bisect each other, which means for the shorter diagonal, those two parts will be congruent. For the longer one, those two parts will be congruent. Okay. All four will not necessarily be the same. In fact, in a regular parallelogram, they never are. All right, but we'll talk about some other shapes tomorrow where they will be. So those are your 5 properties. All right. So the next page, we're going to use these properties to find some missing sides and missing angles. All right. Now, for the notes, we're going to explain the reasoning, which means we're going to say which of those 5 properties we're using. Now let's look at the picture first and fill in some things. Let's do the sides. I'm only given the one side 8, but I know its opposite side will also be 8. I see on the diagonals, I've got one side is marked as 6, so the other side will be 6. I don't know what the other diagonal will be, or if I can even figure it out. We'll see. Now, concerning the angles, all right, again, because our opposite sides are parallel, when I draw in the diagonals, I create alternate interior angles. So if this angle here is 95, then QML will also be 95. All right, that works the other way. All right, because QL is parallel to NM. I've got another pair of alternate interior angles, so this one will also be 35. Now together, if I add those together, right, this angle will be a total of 130 degrees. So remember that these will be supplementary. So if these two angles together are 130, then angle N is going to be 180 minus that. So this angle will be 50. Okay. So that works down here as well. So angle L will also be 50. And angle Q altogether is the 130. All right. So let's see what they're asking for. So first they want the measure. Notice there's no bar above it. So the measure of side LM. Let's see if we have enough information. I think I might have forgotten to fill in a number. So let's make it up. Let's say that side NQ is 5. Now I can figure it out. So I know that side ML will also be 5 because opposite sides are congruent. All right, the measure of LN, L to N is the whole diagonal. All right, well, since we know both halves are 6, just add those together, we get 12. And we're using the rule that the diagonals bisect each other. The measure of angle LMN, so M is the vertex, and then if I trace LMN, it is the big angle, the two together, so that's the 130 degrees. Okay. Now remember, we were given the 95 and 35 up here, so we're using the opposite angles are congruent property. The measure of angle MNQ, M up to N out through Q, is then this whole angle, which we got to be 50, and we were using the property, I should say, that consecutive angles are supplementary. The measure of angle QMN, we knew that was 35 because of the alternate interior angles. And that came because opposite sides are parallel. That's how we knew that we had alternate interior angles. And then the last one wants the measure of QL, Q to L. And we knew that that was 8. Again, that was because opposite sides are congruent. All right, so you'll be working some problems like that. And then you'll also be doing more algebra problems, like in number 2, where it wants us to solve for the missing variable. So you have to look at the part that's given, and these are opposite sides. And so we're going to use the property that opposite sides are congruent, so we'll set them equal to each other. All right, so we get the x's on the same side. And then we get the numbers on the same side. And we're going to end up with x equals 27. In letter B, the two angles that are given are consecutive. So consecutive angles are supplementary. So we're going to add 20x plus 16 plus 8x minus 4 and set it equal to 180. So we've got 28 x's. 16 minus 4 is 12, equal to 180. Subtract 12. We get 168. And then divide 168 by 28, and we get 6. All right, and letter C, we're told that K to M, which is one whole diagonal, is 4x plus 14. And that was the whole angle, or the whole diagonal, sorry. K to N is x plus 15. That's just that half. So what relationship do those have? Well, if the left side is x plus 5, so will be the right, because the diagonals are bisected. So I can simply add x plus 5 plus x plus 5 equals, or I can double it. All right, so 2 x plus 5s will equal 1, 4x plus 14. All right, distribute. So we've got 2x plus 10 equals 4x plus 14. And then I'll subtract. I've got 10 equals 2x plus 14. Subtract the 14 and divide by 2. All right. Typically, we do not get negative answers for our x. But if I do substitute it back in, it does still give me a positive answer, right? We're going to have negative 8 plus 14 is 6, and then negative 2 plus 5 is 3. 3 plus 3 does equal 6, so it will check out. All right, now I'm going to stop the video here. We're not done the notes. We are going to continue with proving, but I'm going to stop the video so that you can go do the first part of the practice worksheet, just using those 5 properties. All right. Let me know if you need help.